Hi everybody, this is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to see problems on double and triple integrals. In the last session, we have discussed double and triple integral in two different sessions. And there we have learned how to take variable limits if limits are not given, and in triple integrals also how to take the variable limits. Now let us see few more examples on double and triple integrals. This is a problem solving session of double and triple integrals, unit 5 of matrices and calculus. In the very first question, we have integral of 0 to 2, integral of 0 to x, y, dy, dx. We can see that there are two integral values are there, and two x and y limits are given. Now, in the first one, he has given from 0 to x. That means among the two variables, the limits belongs to y. The limits belongs to y. That means we need to take y from 0 to y from y to x. So, here, this I can write it as integral y from 0 to x. Now, x will be eliminated. So, we are going to have single variable x from 0 to 2. Y dy dx. So, integral of x from 0 to 2, you can write it as y raises from 0 to x, y dy dx. Integral of y is y to the power of n plus 1 divided by n plus 1. You all know that integral of y to the power of n dy takes the formula of y to the power of n plus 1 divided by n plus 1. Use the same formula. So, you are going to get it as y to the power of 1 plus 1, which is equal to 2 divided by 2 limits are taken from 0 to x. Limits are taken from 0 to x. That means in place of x, first we need to substitute the upper limit, then the lower limit. Now, upper limit is y is equal to x, so it becomes x square minus y 0, which is nothing but 0. So, x square minus 0 divided by 2. So, you can take this outside, and the remaining is nothing but x value, only one variable. So, the double variable is converted into the single variable. Now, use the same formula, and integral of x to the power of n, which is nothing but x to the power of n plus 1 divided by x to the power of n plus 1 divided by n plus 1. Using this formula, the integral of x to the power of 2 is x to the power of 3. 2 plus 1 divided by 2 plus 1, that is 3. 2 into 3, 6. Now, it is free from integrals. Now, we need the only last thing that is left out is applying the limit. The upper limit is 2 and lower limit is 0. So, you are going to get 2 cube. 2 cube is nothing but 8. 8 minus 0, which is nothing but 8 by 6 or 4 by 3. So, this is the value. This is how we can solve the problem of double integral, and which is very simple. Now, going to the another example of double integral. Here, the function is double integral. The function is x into x square plus y square dx dy. Now, here both the limits are not fixed limits. One is fixed limit and another one is variable limits. So, in that case, what we can do, we have to choose to which variable the limits belongs to. Now, there are two variables are there. The limits are in terms of x. That means they are the limits of y. So, y raises from 0 to x square, and after integrating the first part, we are the leftover variable is x, and x raises from 0 to 5. X raises from 0 to 5. So, when you are doing a different integral with respect to y, the x has to be taken as a constant. That means only the integral will go for y square. So, this can be written as x into x square, x cube plus x into y square. So, integral of this is nothing but x cube y and plus y cube by 3, y cube by 3. Now, this is what we got it, and now you need to apply limits for y value. Y value, the upper limit is x square and lower limit is 0. So upper limit is x square. In place of y, we have to take x square. So x cube into x square plus x into x square whole cube divided by 3. Now, the lower limit is 0 because there are two terms. In each term, we are having y. When y is equal to 0, both the terms will go to 0. So, your left out function is x cube into x square plus x into x square whole cube by 3, which is nothing but x to the power of 5 plus x to the power of 7 by 3. So, x to the power of 5 is nothing but x to the power of 6 by 6 plus 1 by 3 into x to the power of 8 by 8. Now they'll apply the limits. If you apply limits, what you're going to get? 5 to the power of 6 by 6 plus 5 to the power of 8 by 24. If you want, you can even write this in the least form also. So in this way, the variable limits are operated in double integrals. First, we need to do the variable limit, the derivation, the integration for the variable limit. Then convert the double variable function to the single variable, and then the single variable is integrated, and upon which you are going to get the numerical value. Now, next example, third example, integral of 0 to 1, integral of 0 to root of 1 plus x square dy dx 1 plus x square plus y square. That's the equation, and the function is a rational function 1 by x square plus y square. Now, keeping the function apart, aside. Now, you look at the variables. The variables are there from 0 to root over 1 minus x square. That means these are the values of y. So, the first the y variable is eliminated. The function is reduced to x. Then the x integral can be done. Now, into 1 plus x square plus y square. Now, 1 plus x square you can take it as constant. You can take it as constant, that is a, and we will write this 1 plus x square as root over 1 plus x square whole square, so that you can compare this with 1 by x square plus a square dx integral, and which is nothing but 1 by a tan inverse x by a, 1 by a tan inverse x by a. So the integral of this 1 by x square plus y square, x square plus a square dx is nothing but 1 by a tan inverse x by a. Here a is nothing but root of 1 plus x square. So 1 by 1 plus x square tan inverse 1, that is tan inverse x by a, x by a. So y by here x is nothing but y is taken from 1 minus x square by 2. Y is equal to 0 to root over 1 minus x square. So upon applying the limit, you are going to get it as tan inverse 1 minus tan inverse 0, tan inverse 1 minus tan is, because we are substituting this value. Look here, tan inverse, what you have? Tan inverse y by root over 1 plus x square. Now, you apply the limits from 0 to root over 1 plus x square. That is the y values. So, if you substitute y values, what you're going to get here? This becomes tan inverse root over 1 plus x square divided by root over 1 plus x square, okay, minus tan inverse y is 0, tan inverse 0. These two gets cancelled, that is 1. So you are going to get it as tan inverse 1 minus tan inverse 0. So this is how we have got the value, and tan inverse 1 is nothing. You can you can also write like this also, that is pi by 4 sine inverse x from 0 to 1, or pi by 4 sine h inverse 1. Even like this also you can able to write. So tan inverse 1 minus tan inverse 0 into dx, which is nothing but pi by 4 tan pi by 4, tan 45 degrees is nothing but pi by 4. So pi by 4 integral x raises from 0 to 1 by root over 1 plus x square dx. So pi by 4 you take common, log of x plus root over x square plus 1, and upon the limits from 1 raises from, x raises from 1 to 0, x raises from 1 to 0. 0 to 1, sorry. So that is nothing but pi by 4 log of 1. X is nothing but 1 plus root over 1 plus 1. Okay, that is 2. So this is nothing but 1 plus root over 2, and then the second term becomes 0, log 0. So this is the numerical value for this question. Now let's go for the next equation. Next, evaluate integral double integral 0 to 4, 0 to x square, y by x, dy dx. First, as I have done the previous problems here also, the y limits are from 0 to x square, because the limits are in terms of x. That means they belongs to the variable y. So 0 to x. So e to the power of y. You know that e to the power of kx is nothing. Integral of e to the power of kx is nothing but e to the power of kx by k. So here you have this k as 1 by x and y. E to the power of y integral is e to the power of y. And the constant 1 by x is taken as a denominator also, just like a previous one. Here also one more example is there. Evaluate integral 0 to 1. Integral x to root over x square plus y square dx dy. Even here also these are from y raises from x to root over x, and x raises from 0 to 1. In the third case also the same thing. You can try these questions 5th, 6th and 7th, and answers are also given in order to verify your check your solution, so whether it's correct or not. Now the next question, evaluate integral 0 to x by pi by 2 integral -1 to 1 x square dx x square y square dx dy. Now look here, now both are fixed integrals. That means if both are fixed, we need to follow the internal differentiation, that is, this is to be taken 1 and this has to be taken 2. That means these are the variables of x and these are the variables of y. Now integral of y square is nothing but y cube by 3, and integral of x is nothing but x cube by 3. So x is taken from -1 to 1. So which is nothing but 1 cube minus of -1 cube divided by 3. Okay, and into the next one, that is y cube by 3. Y cube by 3 you have from pi by 2 whole cube. That is nothing but pi cube by 36. The total answer is pi cube by 36. So similarly you can try the other two problems also, and let's go to the triple integrals. Let us take some examples of triple integrals. Now you all know that in triple integrals the volume of the function can be founded by triple integral of f of x comma y comma z of dv, that is which dv is nothing but dx dy dz. Here the three variable questions will be there. Let us take one example of how to give the volume. Evaluate the following integral, that is a triple integral of 8xyz dv. Now 8xyz dv. Now the limits are taken from 1 to 2, 2 to 3, 0 to -1. Now you follow the order dz, dx, dy. Then these are the values of z, then these are the values of x, and these are the values of y. So first we need to integrate z value. So double it. You are going to get integral 1 to 2, integral 2 to 3, 4x y z square. Z limits are from 1 to 0. So that 1 square minus 0 square, which is 1. So z variable is totally eliminated. The function is reduced to 2 variable question. Now again the y limits, x limits are given 4x square by 2, 4x square by 2. Okay, and the remaining is nothing but y. Y is nothing but y square by 2. Substitute all the limits, you are going to get the value as 15. So this is how we can do the triple integration, and in this question we have all the three variable limits are taken as constant. Now next question, evaluate the triple integral 2x dv, where E is a region under the plane 2x plus 3y plus z is equal to 6 and lies in the first quadrant. Now this is the first quadrant. This is the given region here which lies in the first quadrant. So you can either bring the x value in terms of y and z, or y value in terms of x and z. So anything here. Suppose if you are going to take y values in terms of x and z, so minus 2 by 3x plus 2, and x value minus 3 by 2y plus 3. Okay, here as this is xy plane we are taking x as 0. So easily we can convert like this. So let us see what the integral becomes. Triple integral of 2x dv becomes double integral of integral 0 to 6 minus 2x minus 3y to 2x dz into dA. Okay, so that is nothing but double integral of d 2x z, because we are doing with z first, because these are in terms of x and y. So z first. So z, and our lower limit and upper limits are 0 and 6 minus 2x minus 3y into dA. Now third one, integral 0 to 3, integral 0 to minus 2 by 3x plus 2x 6 minus 2x minus 3y into dy dx, and which is nothing but integral of 12xy minus 4x square y minus 3xy square, and which are taken from the limit 0 to minus 2 by 3x plus 2. So you apply the limits here. So you are going to get it as integral 0 to 3 4 by 3 x cube minus 8x square plus 12x into dx, and which upon integrating x cube, different integration is nothing but x to the power of 4 by 4 gets cancelled, minus x cube by 3, that is nothing but 8 by 3 x cube plus 12x square by 2 and that is 12 by 2, which is nothing but 6. So 6x square, and again you apply the limits for the x value 0 to 3, and this is we are going to get it as 9. So this is a numerical value for the triple integration of the second question. Now this is how we can do the triple integral questions very easily. Now you once again, the triple integral of a function is represented by triple integral of f of x comma y comma z into dv. Now the functional value will be given. Now mostly in these questions the integrals the limits values we need to calculate first. So 8xyz dv, he himself has given the values, and all the three are fixed limits. So directly we are following the internal differentiation, that is dz first, dx the next, and this is the dy. So if all the three are fixed limits, follow the differentiation that is there inside the integral. If any one of it is a variable limits, then the question arises, the limit, the order of integration will based on the limits that are given, if they are variable limits. So here I have 8xyz, which is nothing but z square, and z after substituting the limits, z will get eliminated and the remaining function reduces to x and y. And upon integrating y, you are going to get y square, and y apply the limits, and also the y is also eliminated, and the remaining function is in terms of x and or y. Because any one you can take first, there is no harm in here. We don't get any wrong solutions, because these three are fixed limits here. Now next question is triple integral of 2x into dv, and E is a region where the plane taken from 2x plus 3y plus z is equal to 6. Here the limits are taken. How the limits are taken, that is a question. Here we are let us understand, let us say that the plane is in xy plane, then that let us say that it is in xy plane, that means z is equal to 0. So the limits are from 2x plus 3y is equal to 6. So either of the way you can, there are two options are there here, that is 2x is equal to 6 minus 3y, or x is equal to 6 by 2 minus 3 by 2y. This is one option, and you are going to get it as 3 minus 3 by 2y. This is one option, and another option is you can take this 3y is equal to 6 minus 2x, and y is equal to 6 by 3 minus 2x by 3. Okay, and this upon cancelling we are going to get 2 minus 2x by 3. This is a second option. So either you can have the variable limit of x in terms of y, or y in terms of x. If you are taking the first option, x in terms of y, the question is in the question wherever x variables are there are converted into y. then in that case you need to get the y value fixed. So how to get the y value fixed? In order to get the y value fixed, again in the plane you put x is equal to 0. So what you going to get? 3y is equal to 6 or y is equal to 2. So you are taking from the origin, that is the line, x-axis line to the line. So y is equal to 0 to y is equal to 0 to y is equal to 2. This is the height you are taking. Suppose if you are converting taking y as a y in terms of x, then the question is converted into x variables. Then you need to get the x limits. So how to get it? Again in the same take the same plane, put y is equal to 0. So 2x is equal to 6 or x is equal to 3. X is equal to 3. That means y x values, if you are taking as a fixed values, they should be taken from 0 to 3. If you are taking y values, then then any one option you can apply. Both the things at a time we can't apply. Any one, either convert all the functions in terms of x and give the x as a fixed limit, or in terms of y and give the y limits as a fixed limits. In this question the functions, see the 0, it's taken from 0 to 6 minus 2x minus 3y 2x dz into dA, and which is nothing but we are doing with z. Therefore the z here function is z of z is variable of z is not there here. So integral of 1 dz is nothing but z. So apply the limits for upper and lower limit. So upper and lower limit, upper limit is 6 minus 2x minus 3y, and lower limit is 0. So which comes out to be 12x minus 4x square minus 3xy. So upon integrating with respect to y, you are going to get it as 12xy minus 4x square y minus 3y square. So again apply the limits wherever y is there. Put upper limit as minus 2 by 3x plus 2. Next the minus the lower limit, that is 0. So you are going to, the function is converted into integral of 4 by 3 x cube minus 8x square plus 12x plus, into dx, and upon integrating x cubed integral is x to the power of 4 minus, and x squared integral is x cube, and x integral is x square. So 1 by 3 x to the power of 4 minus 8 by 3 x cube plus 6x square, and again you apply the upper limit and the lower limit. Wherever x is there you can put upper limit, that is 3 to the power of 4 81 by 3 minus 27 into 8 by 3 plus 6 into 9. So minus 0, because all the three terms are containing x. If you substitute x is equal to 0, what you are going to get? The second limit, the terms of the second limit is completely reduced to 0. So the answer comes out to be 9. So in this way you can do the problems on triple integrals. Thank you. Sir? Discard and go tala.